The first thing we'll do will be to draw our plane mirror, and we represent plane mirror with a straight line and those dashes on top. Next will be to mark out our normal. Our normal is 90 degrees to the plane mirror. I will call it N1, and our first mirror will be M1. After that, we'll draw our incident ray to that point it meets the plane mirror, and that line is our incident ray. We'll also denote it as I1. After which we'll also mark out our normal as normal. Then we'll draw our reflected ray. So that ray is our reflected ray. You can see the direction of the arrow. So that's our angle I, and that's our angle R. So from the law of reflection, I is equals to R, which means this entire angle can either be 2R or 2I. So we are just going to call it 2I. The next is to rotate our mirror about an angle. So once we rotate the mirror, we shift it about an angle, leaving the incident ray as it was before. So that's the angle we rotated our mirror about. We'll get a new normal. That's a new angle 90 to that new position of the mirror. And it will also be about the angle theta, that same theta. Since our incident ray is constant, we'll get a new reflected ray, and we'll call the initial reflected ray R1 and the other one R2. And we'll call that angle X, which is the angle we are looking for. Now, for our initial reflected ray and our new normal, our angle of incidence is I plus theta. While for the new normal and the new reflected ray, our angle of reflection is also I plus theta from the law of reflection. Now, to get X, we'll do the entire angle minus 2I. That's the entire angle minus that angle minus this angle here. So the entire angle minus that angle will give us the angle of rotation of our reflected ray, and that's I plus theta minus 2I, and that will be equals to what? 2 theta.